How are you, everybody who is watching this video? My name is Olenjolai Mokota Yailo Singo from beautiful, fantastic country that called United Republic of Tanzania. I would like to welcome you into our official YouTube channel that's called the Online Undergraduate Polytechnic Institute of Tanzania, in square bracket Olenjolai M. So this is the abbreviations of the word undergraduate. It means that bachelor degree, and this is the poly, these four letters. This is the abbreviations of the word polytechnic, and this bunch of these six letters, next letters, these abbreviations of the word Institute of Tanzania Olenjolai M. So in this official YouTube channel that we are solving a complex problems for undergraduate students, especially that for the African students or for the students studying in African continents, especially that in Tanzania, that when I've been doing my undergraduate studies, I realized that many students, they fail to understand different concepts of engineering and scientific mathematics. So that's the truth. So I'll be solving these problems by sharing or by teaching what I know, or the small knowledge that I have, a little knowledge that I have about probability and statistics, about engineering and scientific mathematics. I don't know everything. I just know a small slices of engineering and scientific mathematics, but I'm ready to teach by using simple approach and teaching aids, different teaching aids, different teaching techniques, so that every student can take this course and understand and enjoy the beauty of engineering and scientific mathematics. So in order for you to stay connected, I would like just you to insist you to do the following things. The number one, make sure that you subscribe onto our YouTube channel, so that once we upload any new video, because we'll be adding new videos into this official YouTube channel, so the YouTube community will give you notifications when you are online. Secondly, I ask you that also to read the descriptions of each video, so that you can get some more information concerning about even some other links that you can share with your young brothers, young sisters concerning about academics. We are very serious. We are very focused on this business. Okay, number three, I will ask you also that to share these contents with your young brothers, young sisters, your colleagues, your classmates, your O-level classmate, your A-level classmate, you see, your diploma classmate, because this is a program for undergraduates, and the syllabus which will be used is for undergraduate level. I will never teach anything else concerning about diploma or O-level or ordinary secondary schools or advanced secondary schools in this YouTube channel. Well, so that is number three. Make sure that you share this content with your colleagues. Number four, our classes will not be complete without questions from the students. So how will you ask questions? That's the very important questions in your mind, that know that is clicking as well. You deliver these contents, but how you can interact with me, that's the good questions. You can use the comment section here to ask your questions in each video, and I will try my level best to answer them. And even some other students worldwide, they can answer your questions, and also you can use the comment section to establish online group discussion. So it's a time for the digital technology just to impact the life of students. So that is very essential and important information. Again, lastly but not least, point of focus, it means that I'm very serious in this program. I've been teaching probability and statistics for almost four years for the physical teaching or for the physical trainings for undergraduate students at the Islam Institute of Technology. It doesn't mean that maybe I know everything concerning about probability and statistics. I just know a little portion, as I said, and I would like to repeat several times. So make sure that you go through from the beginnings of the course to the end. So we have bunches of lectures, lecture 1, lecture 2, lecture 3, lecture 4, lecture 5, until we finish the topic. We'll be solving many problems. We'll be solving different questions from different past papers, from different engineering and scientific mathematics books, so that you can enjoy the beauty of engineering. However, that later on, we might even learn that how do we apply these concepts in engineering. Right? Different fields of engineering. We might think that how we can apply in real life on solving problems. But another thing, that throughout the course or throughout the programs that I will be teaching you how to think differently. So in case that you find maybe I'm teaching faster or quickly rather than your speed of understanding, you are allowed to repeat or to means that to watch this video several times as well as you can until those concepts click in your mind and stay there for the rest of your life. So I believe that you have all the introductory and all the informations which are essential for you to go through. So today we are in departments of engineering and scientific mathematics. The modules or the course is probability and statistics, and the topic is statistical estimation. This is chapter 0, topic 3. You have studied in some of the universities. They start this course in first year, second semester of first year, for example in University of Dodoma, and even many of the universities worldwide, they start this course at the second semester of second year of engineering or scientific program. This is lecture 3, and in this lecture 3 is titled like this. So this lecture 3 is titled today I'll be teaching about interval estimators of the mean of normal population with non-population variance. Interval, say interval. So interval estimator I have taught you interval estimators of mean, not standard deviation. Okay, so I will be starting on interval. I'll talk about the point estimator of mean of a normal population with known population variance, with known population variance. With known population variance. So the quick review is in the session 2. I told you about point estimator. Just a quick review of lecture 2. So in lecture 2 I talked about point. Basically in this lecture I talked about point estimation about mean, right, about mean. And then point estimation, so I talked about point estimation about what? About standard deviation, about variance. And then I talked about point estimation about 30, about standard deviations. But I left the homework for you. This is homework 2, right? And the questions will say that a random sample of 9 electronic components produced by the certain companies is the following sizes in suitable units: 1,211, 1,224, 1,187, 1,208, 1,220, 1,216, 1,213, 1,198, 1,197. What are the estimates of population standard deviations and the population variance? So it was a very simple question. So just the corrections means that answers. These are the answers. So standard deviation for this problem, so standard deviation is, so I'm giving you the response so that you can check if you are right or not. 10.149. And variance, so it was example 5, it was example 05, okay? Yes, example 05. Then variance was 103. So let us continue with this concept of interval. Today, I would like just to tell you that we are going to enjoy the beauty of probability and statistics for undergraduate level. Because you know that, remember that, what are we dealing with? We as engineers, we want to deal with big data, say big data, right? Such as, for example, that huge data in computer processing, so in informations, or in civil activities, or in transportations, or in, maybe, for example, that you want to do something or want to solve a particular problems in a certain population. So when we deal with population directly, it's difficult, complex, it's expensive, it's time consumptions, and even sometimes that we might get incorrect parameters or statistical parameters. So what we do as statisticians or engineers or scientists, we take a sample and then use that sample to estimate all the population parameters. And basically we are focusing on 3 population parameters, which is means, variance, standard deviations. But also we deal with something that we call another parameter, we call the proportions. So interval estimations, we say that we want to estimate mean. For example, for this subtitle, interval estimator of mean of a normal populations with non-population variance. We'll be having, for example, we as engineer, we can have a populations which is variance is known, but we want to estimate its mean. Where does it vary? So we have to use different concepts and different estimation techniques. And that's what I invite you now to go through with me. So before we do derivations in this lecture, I'll derive the general formula. I'll teach you about confidence interval in these sessions. I'll teach about the confidence limit, the confidence level, and standardized value. I'll teach about the means. I'll teach about the standard deviations of the finite and infinite population. So I'll just be recalling some of the concepts that we learned in sampling distribution topic. So let me start with introduction of this concept. I will introduce some of the key points for you to understand this business. So you say that what the challenge when we deal with point estimations is difficult. It's impractical to use point estimation in case that you have a large population. So when we estimate a parameter, a statistical parameter, right? So a statistical parameter by a quantity estimate, right? By a point estimator. Okay, what do we encounter? We don't expect the resulting estimator. We don't. We as engineers and scientists, we don't expect the resulting estimator to be exactly the same, okay, to the actual parameter, right? To the actual parameter. But we expect it to be closer to it. So the limitations of point estimator, we don't expect the resulting estimator or the estimator to be exactly the same. What do you mean? If, for example, we want to estimate the mean of a particular population by using a certain sample and by using the point estimate of the sample, then we don't expect that the sample mean to be equal to what? To the population mean, but we expect it to be closer to it. So what happens? So how do we solve it? So we as engineers, to be specific, to be more specific, we sometimes try to find an interval, estimator, an interval about a point in which we can highly be confident, in which we can highly be confident, can highly be confident that the parameter lies in between. That is, so we say that to determine, so we need the interval. So we said to determine an interval estimator of a population we use the probability distribution. We use the probability distribution of the point estimator of that parameter. Okay, so we say that determine the interval estimator of a population, so we use the probability distributions of the point estimator of that parameter. So if it is mean, we use the probability distributions. To determine the interval estimator of mean, we use the probability distributions. Determine the interval estimator of variance, we use the probability distributions. Determines the interval estimator of standard deviations, we use the probability distribution. So another piece of information now, I would like to introduce to you, ladies and gentlemen, the concept we call the confidence interval. So the concept that we call the confidence interval. Confidence interval, right? So confidence interval. That's the concept that we want to introduce to you. So we say that what is confidence interval? What is confidence interval? Right? So confidence interval, we say that confidence interval is a measure. So I have two definitions. I found three, but I'll share with you two. In the measure of the probability. Confidence interval, this is the measure of the probability. Measure of the probability that a population parameter, a certain population, a population parameter such as mean or standard deviation population parameter will fall. Population parameter falls between the two sets of 40 of values. That's the meaning of confidence interval. Say confidence interval. Very important word in probability, in statistic estimations, and also in hypothesis. Very important terminology. So confidence interval is the measure of the probability. So this is the measure of the probability that a population parameter, so it measures that a particular population parameter falls between what? Between the two sets of of values. What does it mean? For example, we can say that maybe mean lies between, so for instance, we say that maybe we have 2.3 less than or equal to mean of population less than or equal to 3. So the mean of populations lies between 2.3 and 3. So that's what we call the confidence interval. So we are confident enough. We can have a degree of confidence, so we call it confidence level. That maybe we are confident enough by 95% that the mean of a particular population lies between 2.3 and 3. So that's what we call the confidence interval in mathematics. So that's the measure. So we say that is a measure of the probability that the population, a particular population parameter, lies between two sets of values. It might be the set of, it always is a set of real numbers. So that's one of the definitions. We say that the confidence interval can take any number. Okay, so against that I want to add some more information. We say that according to this source, confidence interval can take any number, right? Tell your neighbor, confidence interval can take any number. So confidence interval can take any number, right, of probabilities. Of probabilities with the most common being, common being, so these are the most common being, are 95% and what? And 99%. So this later on we call it 5% and this is 1%. So we call confidence level here it is 5% and confidence level here it is 1%. So we will see it. Okay? So that's one of the definition. But again, some of the resources, for example, the Wikipedia define the concept of confidence interval in this way that in statistics, so or confidence interval, so you say that in statistics, a confidence interval is a type of interval estimate. Okay, interval estimate of the population parameter. Of the population parameter that is computed from the observed data. That is computed from the observed data. So that is according to Wikipedia. It defines the concepts of confidence interval. Define the concepts of confidence interval as what? As is a type of interval estimator of the population parameter that is computed. So we computed it from the observed data in a particular experiment. So we say that again we have a piece of information that a confidence interval is always accompanied by what? By another concept that we call it confidence level, by a confidence level, okay, which tell us how likely it is. So this the confidence level, want you to understand, tell us how likely it is, that the interval estimate actual captures. How likely it is the interval estimate capture the truth, we are seeking. Truth that we are seeking. Okay. So the common confidence interval level used in research and in the media is 95%. 95 and 99, but the common one is 95%. So let me add this piece of information before we go to the another concept that we say the common confidence interval. Remember that this subject is used likely in research. Common confidence interval used in research is what? Is 95%. 95%. So now we have a new terminology we call the confidence level. Say confidence level. This is the parameter that accompany the confidence interval. So the fundamental question that we have to ask ourselves is, what is confidence level? That's the question that we have. So confidence level is a frequency. Confidence level is a frequency. Let's say it's a proportion of confidence interval confidence intervals that contains that contain the true value. That contain the true value of the year corresponding parameter. The year corresponding parameter. So we say that confidence level is a frequency or is a proportions of confidence intervals that contain the true value of the year corresponding parameter. See? So is a frequency. How frequency, right? So this is the measure of the confidence interval that contains the true value of the year corresponding parameter. So that means of confidence level, how confident you are that the mean of particular populations range between the minimum value and the maximum value. How confident am I that the standard deviations of particular populations range between the minimum value to the maximum value? So that the means we call it in mathematics or in probability and statistics, which is a very beautiful and fantastic branch of mathematics. That's what we call confidence level. Remember that we have a lot of mathematical problems that we'll be solving along. So don't think that maybe it's more description modules or course. These are just the minor or just the, it's an introduction, okay? So again, after introduction, we have three factors. We have three factors. What are the factors that affect the confidence interval? Three factors that can affect the width of what? Three factors that affect the width of confidence interval. Confidence interval. So there are three factors that affect the confidence interval. The first factor, the sample size. The sample size. The sample size that has been taken from what has been taken from the population. So the sample size, right? So when the large sample, we say that a large sample produces what? Narrow intervals. Narrow intervals, right? Narrow intervals. So what it means of narrow interval, for example, that you can have maybe, you can have maybe the mean range from 3.1 less than mean, less than or equal to, or less than, let's say, 3.22. So that's the narrow interval. So that's the first factor which can affect the width of 40 of confidence interval. You're warmly welcome if you're joining with me right now. My name is Olejulai Moko from Tanzania. I would like to welcome you into our official YouTube channel that's called Online Undergraduate Polytechnic Institute of Tanzania, in square bracket Olejulai M, and this is the engineering, this is the departments of engineering and scientific mathematics. So you're only welcome. The second factor that can affect the width of the confidence interval, we call it in statistics the natural variability among the units in the population. The natural variability. The data has been collected from the site. Variability. The natural variability. Okay, the natural variability among the units. Among the units in the population. In the population, or so in the population. So say that the more natural variability results in the width of intervals. So what means of natural variability? we say that, for example, we have collected a certain data, and then we find that we have a high variability, for example, from 10 to 30. This is high variability, natural variability of the data. So we find that what happens is that we say the more the variability, the more the variability of the data, we say that the more the intervals, the white, okay, or the more the variability results wider interval, result in wider intervals. So wider intervals. So that is a very important piece of information, but another, so let us see the variability of how this factor can affect it. Let us see the variability of the confidence levels, and then how it can affect the standardized value. So there's a table below. The table below, this shows, what does it show? Shows the values of standardized values, the values of standardized value, which is Z subscript of C, corresponding to various confidence intervals. Corresponding to various confidence levels. Correspond to various confidence levels in practice. Okay, in practice. So let us see this. So let me claim the first or the last two lines, so to have more space, because you have noticed the subtitle. So this is, so you have a table here. Okay. This is standardized value, Z is subscript of C, and then here we have confidence interval. This is confidence level. So how do we determine these values? In many questions you'll be given the confidence level, and then you'll be asked to find the confidence limit. So in order to find the confidence limit of about mean, maybe, for example, then we need to know the standardized value. So we use the standardized, means that the normal distributions standardized table in order to determine the standardized value. Sometimes some of the students, they can claim this table, but I don't advise you to claim. No need for you to claim. I will just teach you the simple approach that any confidence level will be given, you can know its standardized value. So the first standardized value is 3.0, and hence here the confidence level is 99.73%. Then you have 2.58. Then its corresponding value is 99%. Then you have 2.33. Then its corresponding value is 98%. Then we have when the confidence level is 96%, its corresponding standardized value is 2.05. When the confidence level is 95.45, its corresponding standardized value, which is 2.00. When the confidence level is 95%, its corresponding value is 1.96. When the confidence level is 90%, we are confidence about for 90% of the values range, so its corresponding standardized value is 1.645. When the standardized value is 80, when the confidence level is 80%, then standardized value is corresponding standardized is 1.28. When the confidence level is 68.27, these are the usefuls of this level. Standardized value is 1.00. And then we have when the confidence level is 50%, this we call it in statistics probable error. I will teach you. I have one problem on dealing with this concept of probable error. So that's the range. So even we can make some of the lines that this is the first row, this is the second row, this is the third row, this is the fourth row, this is the fifth row, and this is the sixth row, and this is the seventh row, and this is the eighth row, and this is the ninth row. That's the last one. So some of the teachers and even some of the students, when they're being suffering on dealing with confidence level, they can pen this confidence level as their corresponding standardized value. Because in many problems, we'll be given a confidence level, but we don't understand standardized value. I don't advise you to do that because you are an engineer who we expect you to solve a real life problems, and not even one, more than one, in your community, in your city, in your country, so that we don't entertain you to claim these issues. I will teach you that if you be given the standardized value, if you be given the confidence level in the problems, I'll teach you how you can use it in order to know its corresponding standardized value by just using the standardized normal distribution table. That's all. So no need for you to claim all of these things. You know that I'm very lazy, and even I used to fail to claim. I used to fail on claim. So I don't know how to teach you to claim the stuff. I'll teach you how you can understand it. So when we be solving problem, I will show you a simple approach for you to find the corresponding standardized value when the confidence level is given. So even if that this is also remember the confidence level in other words we call it probability. So in terms of probability, this is 0.9973. In terms of probability, this is 0.99. So you can use even the standard normal distribution table. You can read that if you can read the probability of 2.58, you'll find that its probability is 0.999. Then 2.33, you'll find its probability is 0.9800. Similar. So this is probably 0.96. 0.9545, 0.95, 0.9, 0.8, 0.6827, and 0.5. That's the probability of assurance, of confidence. It means that how confident you are that that particular population parameter lies within the interval you found or it has been given. Again, before I forget that, if you feel from your heart that you want to offer God the Thanksgiving offering for this program that's coming to you free, which actually that you have to pay a lot of money, it's very expensive to get these programs in person, but I've decided to offer God my Thanksgiving offering. So even yourself, you can offer your Thanksgiving offering through this mobile number. Or if you go through the descriptions in this video, you'll see also the bank transaction. This is mobile transaction. At this moment, we don't have the international modes. I think that we have international transactions, whether mobile international bank transactions, so that you can send your Thanksgiving in order to participate or in order to contribute on the running cost for these programs to make that many lectures of probability and statistics will be online. Okay, so that's the table that we have. The third factor that can affect the weights of the confidence level, this is, we call it the level of confidence desired. The level of confidence. So we call it the level of confidence desired. Okay? So the more confidence we want to have in result, the wider the interval we need to be. So the level of confidence desired, what level of confidence do we need as statistics? So the more confidence you want in a research, you want to have in the result. As a result, the wider the interval we need. The wider the interval we need. So that's the concept. We need to be. So that's the concept that you have to remember. Right? Then, if that's the case now, let us go to the mathematical. We have been speaking mathematical, but more theoretical. Let us learn how to derive the formula of confidence limit for the infinite population. Derivation